Today's lesson, 6.2b, is about using graphs to represent functions. So take a moment, pause the video, and write this down. Okay, so all two variable functions can be graphed on the coordinate plane. So two variable functions generally, for the case of this class, are going to be x and y, which again represent your input and your output. Let's look at an example of a function. So here in Desmos, we can see that our function is y equals 2x plus 1. What that means is that if we input a number for x, we will get out y. So let's just look at this in terms of y equals mx plus b, which we just spent a bunch of time doing. We see here that because it's y equals 2x plus 1, our y-intercept, where it crosses the y-axis, is 1. You can also see here that the x-intercept is negative 0.5. That's not super important right now. So we know also that the slope is 2, which can also be rewritten as 2 over 1. If our slope is 2 over 1, and slope represents the change in y over the change in x, our slope is telling us that if we go right 1, we go up 2. Let's go back and look at that. So looking here, we can see that when x is 0, y is 1. Well, if we go right 1, let's find the value of y at x equals 1. We can see here that when x is 1, y equals 3. So we started at y is 1, and when we added 1 to x, we added 2 to y. So let's look more closely at this graph. Your homework might give you an example that says something like, when the input is 3, what is the output? And in that case, it's telling you, well, your x value is 3, what is your y value? So input will always mean x, output will always mean y. So when my x value is 3, I'm going to track over here to x is 3, and now I need to find the output value at that x value. I'm going to track up and go, okay, from x equals 3, let's go up and find where I hit this graph here. So at x is 3, I now need to find the y value, which if I track over here, I find that the y value is 7. So the correct answer to this, when input is 3, the output is 7. So even if we did not have a graph, we could still do the same thing. So let's say that we're just given the function and we're told, find the output when the input is 10. You're going to have to pause the video here in just a moment. So if we're given the input and we want to know the output, all this is we plug in the number that we've been given for the input, and we solve for the output. So in the case of this equation here, if we are given input equals 10, we're going to remember our parentheses when we're plugging in that number, and we get y equals 2 times 10 plus 1. Remember that because of PEMDAS, we cannot add these numbers. We have to multiply first. So we're going to end up with y is equal to 20 plus 1, and y equals 21. Okay, now sometimes in your homework, you're going to be given the output value, and you will be told to solve for the input value. Let's do an example of that first with a graph, and then without. So here we're asked, when the output is 7, what is the input? Again, we have to remember that output always represents y and input always represents x. So this is telling us our output is 7, and we need to find the x value at that point. So from there, we're going to go either left or right until we hit the graph, which we can see we have to go left. And we find that the y value is 7 at this point. We now need to find the x value of the graph here, so we're going to track down and find that x is negative 6. So let's try this again, and this time we don't have a graph. We're told when the output is 21, what is the input? Again, we have to remember output is y, input is x. And from there, again, we're just going to plug in the value 21 for y. So we'll now have the equation 21 is equal to 4x minus 5. Now this one's going to be a little bit more complicated than the previous example, and pretty much anytime you're given the output and need to solve for the input, it's going to be a little bit more complicated. We SADMAP and we add 5 to each side. Oh, gross. And then we have to divide both sides by 4, and we'll get 26 over 4 is equal to x. This can also reduce to 13 over 2 if you divide the top and the bottom by 2. So let's do one more quick example. You're given a graph and you're told that the output is 3, and you need to find the input. So again, remember, output is y, input is x. From here, we go to the place where the y value is 3, so 1, 2, 3. And we need to track until we hit the graph to find where the graph exists at y equals 3, which is right here. From here, we need to find the x value, so we're just going to go down until we hit that axis, and we find that x is equal to 12. The last part of this lesson is learning how to write a function rule or an equation for the graph. So this is going to be us writing a y equals something for this picture here. And we're going back to our very favorite friend, y equals mx plus b. You should remember by now that m represents the slope, while b represents the y-intercept. And as a quick refresher, I'm going to rewrite the definition of slope on this so that you can copy it into your notes. The slope represents the change in y over the change in x. If you go back and look at your notes from chapter 5, you should remember that if the line is going up to the right, that's a positive slope. If the line is going down to the right, that's a negative slope. So in this case, this line here is going up to the right, which means that this is a positive slope. From here, what we want to do is the following. We're going to pick 2 points at whole numbers. What that means is I want to find nice places where this graph crosses through these grid lines here. So I wouldn't want to pick, for example, here. That's not going to make it easy for us. I do see that the graph crosses through a perfect grid line here, so I'm going to go ahead and put a dot there. And I need to find another place where the graph crosses nicely through a grid line, which I can find right here. I'll draw another point here. In order to find the slope, I now need to find the change in y over the change in x, which I can do by making a triangle. So from here, if I make a triangle, by which I mean I'm going to do this, I can see that the change in y is 1, and the change in x is 1, 2, 3. I remember that my slope is positive, so now I can take this formula that I wrote up here, and I can fill it in with all the values that I know. I know that the slope is 1 over 3, and that's positive, and I know that the y-intercept is where it crosses through the y-axis, which is -1. So if I write a function rule or equation for this graph, that's going to look like y is equal to 1/3 x minus 1.